In this video, we talk about surfaces in 3 dimension and smooth surfaces. A surface is a subset of R3 that looks like a piece of R2 in the vicinity of a given point. To bring the definition of a surface, we need some preliminary materials. One is open set and the other one is homeomorphism. First, let's define an open set. A subset U of Rn is called as an open set if for every point in U there exists a positive number epsilon such that all the points in Rn within a distance of epsilon of the chosen point A also exist in the subset U, then we call this U as an open subset. Now we define the homeomorphism. Let X and Y are the subset of Rm and Rn. If F is a map connecting X and Y, if this map is continuous and bijective and its inverse is also continuous, then we call this F as homeomorphism. Now we have all the tools to define a surface. A subset S of R3 is called as a surface if for every point in the subset S there exists an open set in R3 containing that point and an open set in R2 such that the intersection of subset S with an open set W in R3 is homeomorphic to an open set in R2, that is U. Then we call this subset S as a surface. A subset of a surface S of the form S intersection of W, where W is an open subset of R3, then we call this as an open subset of S. A homeomorphism that existing between the open set in R3 and the surface in R3, open U is in R2 and the S is in R3, then we call this as a surface patch. A collection of such surface patches which forms the whole surface of S is called an atlas of S. Let's look at an example. Consider a cylinder of radius 1 from a fixed axis Z. The simplest parameterization is cos u, sin u, v. But this parameterization is not injective, therefore it is not homeomorphism, because that u sigma of u v is exactly equal to sigma u plus 2 pi v for all u v. So we have to restrict u to be between 0 and 2 pi. This restriction does not give an open set to make it a surface. So to get an open set, then we restrict again u to between 0 and 2 pi. So but this does not cover the whole cylinder. So therefore we need one more open set between minus pi and pi. This covers these two open sets covers the whole surface. So every point of the cylinder now has an image in one of these two open sets. So now then we call this parameterization S with sigma u v as a surface. Let's define what is a smooth surface. We have a map sigma from an open set in R2 to a set in R3. So it is a map between U to R3 from to surface in R3 is called smooth if this map is differentiable to all the orders. If sigma is called, this map is called as regular surface patch if the vector sigma u and sigma v are linear independent at all the points in the U. This regular surface patch is called an allowable surface patch if the sigma is homeomorphism for every point on the surface in R3. If there exists an allowable surface patch for every point in R3, then the surface is called as smooth surface. Thank you.